So question 14 again says find the real zeros of the following equations. So again, real zeros mean we're looking for integers or fractions and decimals, which that all falls under the category of rational solutions. And then irrationals are the ones that involve radicals. So those are all possible scenarios. So again, the first thing we want to do in solving this is identify how many possible zeros there are. And since it's a degree 4, we know there are 4 zeros possible. That doesn't mean there's going to be 4, but there's no more than 4. So again, we can use the calculator. We also can use the zero tool as well. Remember, if we have non-integers, we also can identify zeros using the zero tool on the graphing calculator. There's also, if necessary, we can use synthetic division and the quadratic formula to find any irrational zeros. So if we end up with looking for radicals, that's when we want to use synthetic division and the quadratic formula to do those. So keep that in mind as we move forward. So our first step though is we know there's got to be at least 4. Let's see if we can now put this function into the calculator and let the calculator do a lot of our work for us. So x to the 4th power plus 9x cubed plus 12x squared minus 11x, and then plus the 21. That's our function. So if we now go to the table, we can start looking for zeros. But again, if we use the rational root theorem, we know that the possible rational zeros, again, p are the factors of the 21. So if I make a little t-chart, 21 would be like 1 and 21 and 3 and 7. So plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. The q was the leading coefficient factor. Since it's a 1, it's just plus or minus 1. So the potential rational zeros would be written as p over q. So 1 over 1 is just 1. 3 over 1 is just 3, plus or minus 3. And we'd have plus or minus 7 and plus or minus 21. So that's what we'd be basically looking for in that situation. So if we go to 1, we don't see any zeros there. What about 7? I don't see anything there. Go out to 21. Nothing. Let's go the other direction. Oops, -3 is a 0. So I found 1. -7 is a 0. Found another one. And any others there. So don't see anything. So since we didn't find 4 zeros, what we can start doing is using synthetic division to kind of start to break this down a little bit. So let's start the -3. And we're going to divide -3 into the x to the 4th. So we're just going to use the leading coefficients. So a 1, the 9. Notice how it does count down 4, 3, 2, 1, 0. So I don't have to put any placeholders in there. 1, 9, 12, a -11, and 21. So remember, in doing synthetic division, the first number has to come down. So the 1 has to drop down. So 1 comes down. -3 times 1 is -3. And then we add 9 plus -3 would be 6. -3 times 6, -18. 12 plus -18 would be a -6. We'll double check that one. 12 plus -18 is a -6. -3 times -6 is a +18. -11 plus 18, that's subtraction. It looks like that's going to be a 7. We can double check that as well. A -11 plus 18. That's the same thing as 18 minus 11 is 7. Negative 3 times 7 would be negative 21. And if we add, we end up with a remainder of 0. So that tells me if I pull out the x minus 3, the remaining quotient would be, and since this was a degree 4, this starts out as a degree 3. So what we have now is this x cubed plus this 6x squared minus the 6x plus the 7. And what we want to do is take out the negative 7 out of that. So we want to break that down using the negative 7. So using synthetic division, we can divide that in by negative 7. So this becomes a 1, a 6, a negative 6, and a 7. Give us a little room. So again, remember to do synthetic division, the 1 comes down to start with. So the 1 comes down. And then negative 7 times 1 is negative 7. 6 plus negative 7 would be a negative 1. So I lost 7 and gained 6, so I'm still down 1. A negative 7 times a negative 1, so that's going to be a positive 7. And then 7 and a negative 6 is going to be a positive 1. And negative 7 times 1 is a negative 7, so my remainder is 0. So what we're left with is, since this is a degree 3, this is going to now be a degree 2, so x squared minus 1x, or x plus 1, is equal to 0. So we now have to solve this. It doesn't look like it's factorable, so I need to use the quadratic formula on this. So we're going to use then x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So my a is equal to a 1, my b is equal to a negative 1, and my c is a positive 1. So x equals then the opposite of b, so the opposite of a negative 1 is a positive 1, plus or minus, then in the parentheses, I have a negative 1 squared. I need to put that in parentheses, minus then 4 times a, which was 1, times c, which is 1. And this is going to be all over 2 times a. 2 times 1 would be 2. So x is going to equal then this 1 plus or minus, and I need to do that on the calculator. So a negative 1 in parentheses squared should be a positive 1, minus 4 times 1 times 1 would be 4. So that's really just 1 minus 4. Should be a negative 3. So put that in a calculator like that, I should get a negative 3. So 1 plus or minus the square root of negative 3 divided by 2. So what we pick up on is there's a negative side of the radical, which means that's not going to be a real solution. That's going to be an imaginary solution. That's going to be this I square root of 3 over 2. That's not real, so we can't go there with that. So we only want to identify real solutions. So the only real solutions are going to be the negative 3 and the 7. So I need to take off one of my commas there. So we only have 2 real solutions. The other 2 solutions are actually imaginary. Okay, so that's kind of how we would work that problem out. Use a little bit of the remainder theorem, and then you can use some synthetic division to kind of break it out a little bit, and then it turns into a quadratic formula. If you need to watch this video over again, feel free to do so.